Welcome to Tech Lab by Sid. What is Infrastructure as a Service? IaaS or Infrastructure as a Service is a cloud computing model that provides virtualized computing resources over the Internet. Instead of investing in physical hardware, organizations can rent IT infrastructure such as servers, storage, networking, and other resources from a cloud provider. These resources are available on demand and users only pay for what they use, which provides flexibility, scalability, and cost efficiency. Key components of Infrastructure as a Service. Compute resources. These are virtual machines, or VMs, or instances that users can configure with their desired operating systems, processing power, and memory. The Infrastructure as a Service provider manages the physical hardware, while the user manages the virtualized machine's configuration. Storage. Infrastructure as a Service typically offers scalable storage solutions like block storage, object storage, and file storage, depending on the user's needs. Storage is managed and maintained by the cloud provider, but users have control over how it's used. Networking. Infrastructure as a Service providers offer virtual networks, load balancers, firewalls, and VPN solutions that allow users to securely connect their resources and scale their infrastructure as needed. Security. Infrastructure as a Service includes basic security features such as encryption, firewalls, access control, and compliance tools. However, users are typically responsible for securing the OS, applications, and data on the virtual infrastructure. Virtualization. The core technology behind Infrastructure as a Service is virtualization, which allows a single physical server to host multiple virtual machines, providing efficient resource usage and isolation between different users' workloads. Management tools. Cloud providers often offer dashboards, APIs, and command line tools to help users monitor, manage, and automate their infrastructure resources. Terms related to Infrastructure as a Service. Virtual machine or VM. A software-based simulation of a physical computer that runs an operating system and applications as if it were a separate physical machine. Hypervisor. The software that creates and manages VMs. It runs on the host hardware and allocates resources like CPU, memory, and storage to each VM. Virtual Private Cloud or VPC. A private network within a public cloud that provides isolated resources, typically used to enhance security. Elasticity. The ability of an Infrastructure as a Service platform to scale resources up or down based on demand. This is a key benefit of cloud computing, enabling organizations to handle varying workloads efficiently. Cloud provider. A company that offers Infrastructure as a Service services, such as Amazon Web Services, or AWS, Microsoft Azure, or Google Cloud Platform, or GCP. API, or Application Programming Interface. A set of tools that allows users to interact programmatically with the Infrastructure as a Service resources, enabling automation, scaling, and integration. On-demand pricing. The pricing model where users pay only for the resources they consume, rather than committing to a fixed amount of infrastructure. Load balancer. A service that distributes incoming traffic across multiple servers to ensure that no single server becomes overloaded, improving performance and reliability. Process involved in Infrastructure as a Service. Provisioning. Users start by provisioning resources. They can select VMs, storage, and networking components based on their needs. This process typically involves using the provider's dashboard or APIs. Configuration. After provisioning, Users configure the operating systems, applications, and network settings of the virtualized infrastructure to meet their specific requirements. Management. Once the infrastructure is in place, users need to manage it. This includes monitoring performance, scaling resources, configuring backups, applying security patches, and handling user access. Scaling. One of the most significant advantages of infrastructure as a service is elasticity. When demand for resources increases, users can scale up their infrastructure, example, adding more VMs or storage. Conversely, they can scale down during periods of low demand to save costs. Security and compliance. While the infrastructure as a service provider is responsible for securing the physical hardware and infrastructure, users are responsible for securing their virtualized instances, networks, and data. This can include setting up firewalls, encryption, and access control. Deprovisioning. When resources are no longer needed, users can deprovision them to avoid unnecessary costs. This may involve shutting down VMs, deleting data, or terminating cloud services. Advantages of infrastructure as a service. Cost efficiency. No need for large upfront investments in physical hardware. Users pay for only what they use. Scalability. Resources can be scaled up or down based on demand, providing flexibility for growing or fluctuating workloads. High availability. Cloud providers offer services with built-in redundancy and failover, minimizing downtime and improving reliability. Global reach. Cloud providers often have data centers in multiple regions, enabling users to deploy applications closer to end users for better performance. Focus on core business. Organizations can offload the management of hardware and infrastructure, allowing them to focus on application development and business operations. Disadvantages of infrastructure as a service. Management responsibility. While the provider manages the physical infrastructure, users are still responsible for configuring and securing the virtualized environment, which may require expertise. Potential downtime. While infrastructure as a service providers offer high availability, they are not immune to outages or downtime, which can disrupt services. Security concerns. Since the infrastructure is shared with other users, that is, multi-tenancy, users need to ensure they properly secure their virtual instances and data to prevent unauthorized access. Vendor lock-in. Migrating from one infrastructure as a service provider to another can be complex and costly, particularly if the organization relies heavily on proprietary tools and APIs. Examples of infrastructure as a service providers. Amazon Web Services, or AWS. AWS is one of the leading infrastructure as a service providers and offers a wide range of services including compute power, example EC2, storage, example S3 EBS, and networking solutions, example VPC. Microsoft Azure. Azure offers compute, networking, and storage services, along with integrated tools for machine learning, data analytics, and enterprise applications. Google Cloud Platform, or GCP. GCP provides infrastructure as a service offerings such as Google Compute Engine, or VMs, Google Cloud Storage, and networking solutions. IBM Cloud. IBM Cloud offers both infrastructure as a service and PaaS solutions and is known for its hybrid cloud and AI capabilities. Oracle Cloud. Oracle offers infrastructure as a service solutions focused on database services, compute, and storage, with a strong emphasis on enterprise applications. To summarize, Infrastructure as a service is a cloud computing service model that provides virtualized computing resources like servers, storage, and networking over the Internet. It allows businesses to avoid the upfront cost and complexity of owning and maintaining physical servers, offering scalability, flexibility, and cost efficiency. Infrastructure as a service providers handle the physical infrastructure, while users are responsible for configuring, managing, and securing their virtualized resources. The main processes involved in infrastructure as a service are provisioning, configuration, management, scaling, and deprovisioning resources. While advantages include cost savings, scalability, and high availability, there are also challenges such as management responsibility, security risks, and potential vendor locking. Thanks for watching the video.